Hello everyone, welcome back to the another session. Today we are going to understand about what is finding maximum and minimum problem. Let us consider another simple problem that can be solved using divide and conquer technique to solve or to find maximum and minimum from a set of n elements. Let consider the problem P is equal to n comma a of I to a of j. Denote an arbitrary instance of the problem. N is the number of elements of this list from a of I to a of j. Now, so what is divide and conquer technique we were seen in the last video, and we learned about when the problem is very small, then we will be writing the solution by solving it. When it is too large, then we will be dividing it. Right. As far as this problem is concerned, what is the smaller thing when it will be when the problem will be small? When n value is 1. When n value is 1, the problem will be very small. So max is equal to a of I and min is equal to also a of I, because I have only single element in the list. When my n value is 2, that means this also smaller problem. So I required simple condition to compare a of I greater a of j. So now in this case, we will be finding out maximum is equal to a of I, minimum is equal to a of j. If it is not true, then maximum is equal to a of j, minimum is equal to a of I. If n is equal to 3, that means n value is greater to, then you are going to apply divide and conquer on the problem. Now, so how divide and conquer will apply in this when n value greater to, that we'll see. So assume the scene, P is our problem, where the P is what? N comma a of I to a of j. Condition apply that n value size is greater to. Now this time I will be dividing the whole problem into two sets. The first set is what? N by 2 comma a of 1 to a of n by 2. And the second set is what? P2, which is n minus n by 2 comma a of n by 2 plus 1 comma a of n. So these are what two sub-problems I got from P. Now, how to solve these two sub-problems once after we divide? Now we'll be going to apply. After having divided P into two smaller sub-problems, we can solve them by recursively invoking the same divide and conquer algorithm. Now question comes, how to combine the solution? After finding the maximum and minimum, how to combine the solution? Now let us assume when I am solving this P1, I will be finding out max of P1, right? And I will be finding even max of P2, right? So when I am finding maximum number from this set and this set, I am going to compare these two sets to get the solution back. So this is what the idea of finding maximum and minimum using divide and conquer strategy. Now let's write the algorithm for the same. The algorithm is what? I am taking one function. The function name is max min function. I am using 4 parameters I comma j, max and min. Now just now we were explained that it will be having two smaller cases. When I is equal to j, then max and min is pointing to the same index and the one index which is single element. Now the second case is when I is equal to j minus 1. That means I have only two elements. Now this time I need a single comparison where a of I less than a of j. Now this time a of I less than a of j means what? Maximum element is a of j. Minimum element is a of I. If this condition got failed, then will be going to write else part. In the else part, maximum element is a of I and minimum element is a of j. That's it. So this single comparison is needed when n value is 2. Now n value can be greater to. If n value is greater to, then now I am taking one more case, which is else case. So here n value is greater to. That means p has to get divided. P has to get divided into smaller problems. So when P I wanted to divide into smaller problems, I should know the point to divide it. That means finding out middle element. So now I am going to call the function recursively, that is max and min. Parameters are I comma mid comma max and min. Else part, finding out middle is equal to I plus j by 2 and the recursive function max min I comma middle comma max and min. And this is one part sub problem or one list. The other list is mid plus 1 to j max and min. So this is what two sub list is. Now how to combine the solution? Combine the solution. If one list I am finding out maximum, the other list I am finding out maximum 1. So I am comparing it. Then max is equal to max 1. And one more if case for minimum. Minimum greater than minimum 1. Then minimum greater than minimum 1. That's it. So there are three cases what we were discussed, and these are what dividing and this is what combining the solution. Right, now we'll see one example how these things will get placed through an example. Max and min is a recursive algorithm that finds the maximum and minimum of the set of elements where a of I to a of j. Now the first, I am taking some list, then we will be going to understand easily. So my list of elements are 5, 10. It doesn't mean that you have to take the same elements, or there is no constraint to take only non-ascending order or descending order. The list can be of anything. So I am taking these elements. Indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8 indexes. So 8 means what? My array size is 9. That's what. If you are taking a of n which starts I is equal to 0 means your n value will be n minus 1. If index is started with 1 means you will be go to till n. Now we will be having n value greater to. So that means the third case is going to be performed over here. So when n is greater than 2, you will be going to find out the middle element. So what is middle element? What is I and what is j? I is 0, j is 8. So probably I plus j by 2 means what? 8 by 2, which is 4. 4 means up to 4 we will divide. So that means this is one list. The list is what? 5, 10, 8, 7, 6. So mid plus 1 to the other list, right? This list is what? 12, 30, 40, 20 is the other list. Again recursive operation. So again this list will be going to find out the middle element. Now this time middle is what? 0, 1, 2, 3, 4. 0 plus 4 by 2. 0 and 4. 4 by 2 which is 2. 2 means up to 2 it will be one list. That means 5, 10, 8 will be in one list. The other list is 7, 6. The same will be applied over here. So the one list will be 12, 30. The other list will be 40 and 20. So what exactly we are going to do is, now you found again n greater than 2. So divide it to the two list. 5, 10 is one list, 8 is the other list. Now here, as it is having a single element, it is maximum is equal to 8 and minimum is equal to 8. Now here will be having a comparison condition in the if statement, right? While you are going for combined solutions in the algorithm, in the previous slide, we were seeing about comparison condition. Now, I am taking maximum comparison a of I greater than a of j. Now that means what? Maximum value is what here? 5. N value is 2. We will be executing that first else if condition. So, maximum will be 10. Minimum will be 5. So, now combining solution is what? I am combining maximum 1 with maximum by comparing it. So, maximum is 10. Maximum 1 is 10. Maximum is 8. Maximum 1 is 10. Maximum is 8. Now comparison condition. Maximum greater, maximum 1. So, now the value is 10. From this two list, I am combining the solution. Maximum 1 is what? 10. Here maximum is 10 and the minimum value is what? 5. And from this list, I am getting maximum is 7, minimum is 6. Again, I am combining these two lists. Now this time, maximum is 10 and maximum 1 is 7. So, we will be comparing it up to the top. 10 will be maximum, minimum will be 5. And from this area, maximum is 30, minimum is 12. From this, maximum is 40, minimum is 20. Now combine two back. Compare this 30 and 40. You will get 40 as maximum and 12 as minimum. Now among these two, maximum 1. So maximum 1, if you compare, which is maximum 40. So up to the list, 40 it will come. 5 and 12, 5 it will come. So when you look at this whole list, what the element you will find out as maximum 40, minimum is 5. And this is the way how divide and conquer algorithm will help you out to solve the finding maximum and minimum problem. Now let's see the analysis of the same. So analysis of the same algorithm is what? The recurrence relation of this algorithm. The recurrence relation is T of n is equal to, when n is equal to 1, we will be having maximum and minimum of single statement, right? Now I am taking it as 0 because no comparison we would have required. When n is equal to 2, I am taking one comparison. When n is greater 2, so I am dividing the list into two halves, Tn by 2 and Tn by 2 and some constant statements. So this is what the recurrence relation of finding and maximum and minimum. So now, where n is the power of 2 power k, for some positive integer k, then T of n is equal to 2 into T of n by 2 plus 2. So find out what is T of n by 2. You can find it like this, right? T of n 2t n by 2 plus 2. So n by 2 is what? 2 into T of n by 2 square, which means T of n by 4 plus 2. Now come back and substitute over here. T of n by 2 value is what? 4t n by 4 plus 4. If you take n by 3, it will be again powers of 2. This is what? 2 power 0, 2 power 1, 2 power 1, 2 square, 2 square, 2 square. So finally I am writing the recurrence relation. 2 power k minus 1 of t power 2 sum of 1 less than or equal to I less than k minus 1 where 2 power I. So finally the recurrence relation 2 power k minus 1 plus 2 power k minus 2, that is 3n by 2 minus 2. So it is the best average and worst case number of comparisons when n is a power of 2. So this is about finding maximum and minimum using divide and conquer strategy. Thank you all.